Welcome, intro students, to Periodic Table, Lesson 2. First of all, a little advice. You may want to open up the PowerPoint that I posted that has the same slides as this video does, and use it, refer to it, to help you answer the questions correctly. That way you won't have to redo it. Also, that same PowerPoint you can reference to help you answer the questions in the related Google formative assessment that I will post. So just a little help to try to get you through this. We said yesterday that there are three basic types of elements: metals, nonmetals, and metalloids. And the properties of metals and nonmetals are distinctly different from one another. So imagine, if you will, a metal like aluminum or copper, and think about what it looks like. Metals are shiny. An aluminum can is shiny. Copper wire is shiny. Metals conduct electricity. Most wires that conduct electricity, or the wires in your headphones, are copper, but also silver and gold can be used as well. Metals can be drawn into thin wires, such as the ones inside all of our cords. Metals are malleable, which means they can bend without breaking. You can excuse me, beat on a nail with a hammer, which we do all the time, and it will not break. We can kind of bend or crush an aluminum can without it breaking. Metals have high melting points. Virtually all metals, with the exception of mercury, are solids at room temperature. They have high densities. Metal, relative to nonmetals, feels heavy because it has a high density. Those are all physical properties of metals. One common chemical property is that most metals react fairly readily with acids. For nonmetals, it's pretty much the opposite of metals. Unlike metals, they do not conduct electricity. They are dull as opposed to shiny. They are brittle. If you try to bend or beat on them, they will break. They have low densities, neither ductile nor malleable, non-reactive with acids, and one key thing is very low melting and boiling points. If you look at this portion of the periodic table, the stair step has the metalloids along it: boron, silicon, germanium, blah, 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 blah. So the rest are nonmetals. Most of the nonmetals are gases at room temperature. All of these elements in red are gases at room temperature. Bromine is a liquid at room temperature. It only leaves carbon, phosphorus, sulfur, selenium, and iodine as solids at room temperature. Metalloids are kind of a blend. They're on the border between metals and nonmetals on the periodic table. So they're along the edge here. Here's your nonmetals, here's your metals. So their properties tend to be a blend of those of metals and nonmetals. A metalloid might be shiny. Let's take silicon as an example. It might be shiny like a metal and conduct electricity like a metal, but silicon is brittle. If you beat on it with a hammer, it will break, and it will not react with acids. So it has some of the properties of metals, some of the properties of nonmetals. The next concept is the concept of valence electrons. We know that atoms are made up of protons and neutrons in the center and electrons outside in the cloud. Well, a subset of the electrons are what we call valence electrons. They are the ones in the outermost layer farthest from the nucleus. So they're only the ones on the very outer edge of the atom, and they're pretty much responsible for how the different elements behave. Elements in the same group of the periodic table, same column, have the same number of valence electrons, and because of that, similar properties. And we talked about the periodic table being numbered in two ways, 1 to 18 consecutively, and the A numbers on the tall columns on the left and right. Those A numbers are important because they indicate the number of valence electrons that an element has. Carbon is in column 4A, so it has 4 valence electrons. It has a total of 6, but 2 of them are in a layer closer to the nucleus and 4 on the outside. Silicon and germanium. Silicon has a total of 14, germanium has a total of 32, but because they are in that same 4A column, they also have 4 valence electrons on the outside and 4 valence electrons on the outside. What happens with those valence electrons is that atoms will lose, gain, or share in order to acquire a full set of 8 valence electrons. Now, we talked earlier in the year about metals that lose electrons and become positive ions. Nonmetals gain electrons to form negative ions, and sometimes elements share their electrons to make covalent compounds like water or carbon dioxide. Oxidation number is a fancy word for the charge that an ion gets when it gains or loses to acquire a stable octet. And the number gained or lost depends on the number of valence electrons. This table focuses on just the A columns on the left and right and shows you the number of valence electrons. 1A has 1, 2A has 2, 3A has 3, 6A has 6, 8A has 8, etc. That's really important because that's how we know what kind of ion it's going to make. These numbers should be familiar to you. We use these numbers that sodium is +1, magnesium is +2, sulfur is -2, chlorine is -1. We use those values to determine the formulas for our ionic compounds. So now this gives us a little bit of understanding as to why they form those ions. Sodium has just 1 valence electron in its outer layer. If it can just lose that 1 electron, the previous level will be full with 8, just like neon. It doesn't become neon, but its electrons become like neon. Magnesium loses 2, again, electrons like neon. Aluminum loses 3, electrons like neon. With 4, it could go either way. Lose 4, gain 4, but typically the ones that are in the 4th column tend to share their electrons. Once we get above 4, rather than losing electrons to become like the previous layer, they're going to gain electrons to become like the next noble gas. So phosphorus will gain 3, so its electrons will be like argon. Sulfur will gain 2, electrons like argon. Chlorine will gain 1, electrons like argon. And because the noble gases already have that perfect 8 octet, they don't want to react with anything. Okay, this concludes the Edpuzzle presentation for today. By the way, please let it run all the way through to the end, even after you've answered the last questions. And, I'm still talking here. Please let it run all the way through to the end so that it will show up as turned in. If you stop it before the end, even though I do get a score, it doesn't show up as turned in. Okay? Thank you very much. I will post the Google form as well, and I will be back in touch with you tomorrow.